This is problem 2 in Mod 4. This problem is a lot like problem 1 in that we're going to create a data table. And the data table, again, is for our metric of interest, the net income. And this time we're changing the cost of goods sold and revenue, and I give you information on how to make those changes. I tell you the low value, the high value, and ask you to create a data table. That should be a piece of cake at this point. Part 2 asks you to create a graph that represents what we've gotten here. This is a very special kind of a graph called a surface chart. Let's see how we do that. The first thing that I need to do is to grab my data in my data table, because I can't do it directly from the data table. I'm going to grab it, I'm going to copy it, Control C, or copy. Then I'm going to go here and paste it, but I'm going to paste it with values. And so now what we have in here are values. The values are in there before because I had done it previously, but I've copied over it. And you can see that these are numbers. You can look up here in the formula bar, and you can see that these are simply numbers that are available, whereas what we had here were array values. The next thing I need to do is remove the golden cell from before. So I'm going to exclude it from our analysis, otherwise we get some very strange results. So I take that out, and now we have the data that's necessary to capture for our purposes. We're going to have two dimensions. We're going to have the dimension of revenue and the dimension of percent cost of goods sold, and these are going to be the corresponding values, what you see inside for net income for those various combinations. I find the surface chart in the charts area by looking at this thing. Looks like a little spider web there. That's a radar chart. I can go to the surface area. I can see a variety of options. This is the one I'm going to use, the wireframe 3D, and you can see that it looks a great deal like the one I've got just below. And if we look at the one below, as a matter of fact, they're the same. If we look at the one below, we see that what we have here is a net income dimension, a on this axis, a cost of goods dimension on this axis, and a revenue dimension on this axis. And so these are the corresponding values that are determined from that sensitivity analysis. And as you can see, a very sophisticated sort of a graph. It shows you a surface of values that you can extrapolate values in between. The next part of the question asks us to evaluate the possible changes in three variables: cost of goods sold, variable cost, and tax rate. We have a base case, and we have a low and a high. The base cases have already been established here in this analysis, and all we have to do is to change one variable at a time. In other words, for the cost of goods percentage value changes, I'd go in here and I'd take 0.5 and I would turn it into 0.25, note the value of cost of net income, and then I would change it to 0.75, note the value, and then the corresponding variation would be given to me in this little table here. At 0.25, I get 135.3. Not surprising, the lower the cost of goods sold, the higher the net income is going to be. Here's our base case, and here's our high value, very high cost of goods sold is going to cost me in terms of net income. So I get a negative 95,000 there. And I do it for the three variables. And we could stop there, and that would be enough. And this tells you that the widest variation that you get from these changes in variables is for cost of goods sold, second most, the variable cost, and then thirdly, the tax rate. We can put this into a chart if we want, something called a tornado diagram. The first thing that I need to do is to take this value. I'm going to copy it, and then I'm going to paste it using a special paste called transpose. I'm going to transpose it. So what it does, it turns this set of values orthogonally into this set of values. So on the horizontal, and it's now on the vertical. And I do that for all three values. So here's a series, here's a series, here's a series, and I've turned them into columns, as I usually see in my charts in Excel. So how do I get a tornado diagram out of that? What I'd like to do is get this range of values, and this range of values, and this range of values as three different series. The first thing I'm going to do is I'm going to do a little bit of adjustment. I'm going to subtract 36.3 from all the values in these cells, and these cells to standardize them. So my standard value is 0, and here's the change that occurs, an additional 99,000 up and an additional 131,300 down. So here we have a way of looking at these values, but in a standardized sort of format. How do I get this tornado diagram? Well, I grab the data, I go to Insert, I go to Bar Graph, I go to Stack Bar Graph, and there we have the chart that we see here. I've made some color changes, and there are a few little discrepancies that I can't readily change, like the titles of the series, which I put in there and it has different colors, but we see a single color. But this thing is a tornado diagram. Actually, it's an upside down tornado diagram, because in a regular tornado diagram, this would be at the top, this would be in the middle, and this would be at the bottom. And of course, this just tells us what we saw up here in the analysis we did, but it does it graphically. There you have it, problem 2 in Mod 4.